Thank you very much, Mr. Nikhil, and welcome everybody. Our introduction session for today will be for the course titled Open Hole and Cased Hole Logging in Oil, Water, and Gas Wells. I will present it for 1 to 1.5 hours for today as a preparation for the course that will be delivered next month, hopefully, by me and under the custodian of the PEA. I introduce myself. My name is Sana Shukri, petroleum engineer since 1995, and I have extensive experience regarding completion, workover, well integrity, IWCF, and so on. So after that, if you have anything, you can see my YouTube channel like this, and you can utilize all or most of the lectures that I deliver. This is my email, WhatsApp, Facebook, LinkedIn, and so on. And these are the positions that I hold. Let's move on to the agenda for today. For today, we can introduce the agenda starting from well life cycle, well types, completion types and classification, completion components, wellhead, well intervention methods. Then we can go to the well logging types. This is the main topic in our course. In the open hole and cased hole conditions, well logging after drilling the well, and well logging during production phase. So we have two sections during drilling and during the production phase. The difference between open hole and cased hole logs, the types of well logging. Also, we have many types. We can explain them one by one in details. So we have time during the course. For today, the introduction session, we will not be able to go into details. So we can give the highlight for each type, and after that, we can, in the course, we can give examples, we can take a study case, and so on. We can talk about electrical, radioactive, sonic, miscellaneous, permeability, and lithology logs. So these mainly gamma ray, self-potential or SP, caliper. Porosity logs, we have density, sonic, neutron, electrical, we have resistivity. Special logs, we have FMI, full bore formation micro imager. We have casing color locator log, or CCL. This is very famous log. We have to focus on it. We have also correlation log, gamma ray CCL. Cement bond log, CBL, and variable density log, VDL. Temperature log, radioactive tracer log, noise log, diverting spinner flow meter, continuous and full bore spinner flow meters, corrosion log, reservoir monitoring plan, RMP, and at the end we will finish with questions and answers. So this is the main highlight for our course. Now let's move on to the first section. We can give an introduction for this session, or introduction, or the course, or whatever you call it. After that, we will go into logs that we mentioned a while ago in details, and with case studies, and with everything is related. So for CBL, VDL, we will take cases, we will explain why open hole, cased hole, different cases that at the end of the course, you will be able to recognize the importance of these logs on the well for the future of the well production. If you have a workover, if you have some problems in the well, if you have all of these, as if you go to the doctor, he will ask you to do blood test, pressure test, temperature, X-ray, all of these. Here we are same. We are dealing with the well as if the doctor when he is dealing with the patient. So we summarize the well life cycle of the well with drilling first, then completion, production, intervention, plug and abandonment. Or in other words, we can say design, construct, operate, maintain, and abandon. Where do we use the logging operations? We use it here after the drilling. You see the drilling, after the drilling, or after the completion, and during the intervention. You see the intervention, we run, this is cased hole. Here, we call it open hole. So either open hole or cased hole. We can take the data, do analysis, then recommend for the action that has to be taken. After that, we can take the action. You see here, this is the life cycle of a well. We can start with well construction. That includes the drilling and completion, then production, then maintenance. Here we have the logging is after drilling, and here during workover, and here maintenance. We call it well intervention, and then abandonment. Well, let's take an idea about some principles that we have to understand them before we go deeper and explain about the logging types. We have the wells. We can see two types of wells: exploration or production. This is exploration. We start drilling in this area. It is unknown for us. We call it exploration. After drilling 2-3 wells, we start to drill production well. The well itself, it can be vertical like this, or deviated like this, or vertical then horizontal, 90 degrees. Well types at the production phase. We have oil producer, gas producer, water injector, gas injector, WAG, water alternative gas injector also. We inject water for some time, for 1 month, then inject gas for 1 month, and so on. Water supply well and water disposal well. You see them here. Classification of completion. We have this is open hole completion. This is open hole. You see it? Here we have case perforated completion. This is this one, case perforated completion. This is multiple zone completion. This is dual. This is short string. This is dual long string with 2 packers. You see them, dual packer. Completion types for natural flowing injecting wells. We have single completion, single selective completion, dual completion, and dual selective completion. We see them in the next slide. You see them like this. This we call it, the first one on the left, we call it single vertical completion. You see it? The inclination is almost 0 to 5 degrees maximum. Here, this is single selective. We produce from more than 1 zone. You see the zone 1, this is lower zone, middle, and upper zone. And between them, we set the packer to isolate it. And here we have SSD, sliding side door. Here, if you want to isolate this zone, we can set a plug, and so on. Here we have dual. You see, we inject gas to the lower zone, and we inject water to the upper zone. We call it short stream. Here, long stream. Here we have slim, single stem hole. We don't have completion accessories like nipple, SSD, and so on. We make it 4.5 inch from bottom till surface. Why? We don't want to make any obstruction in front of the production producing fluids. Here we have vertical well and horizontal well. So you have to understand these principles before we go ahead and explain what is going on during the logging operation. We can take an idea about the completion types for artificial lift also. We have 4 types. We have gas lift. You see, this is the gas lift completion. Then electrical submersible pump, ESP, this one. Then beam pump completion, then PCP. Progressive cavity pump, we call it. This is used for very heavy and thick oil. We have motor here. You see this motor. We have rotor and stator. This is stator, rubber here. You see the stator, this one. Okay. This is a stator and this is rotor. We can produce the rotating of the rotor inside the stator. Rotor inside the stator, it can move the hydrocarbons from the bottom to the surface. Here we can talk about the completion components from wireline entry guide. This is a no-go landing nipple, perforated pop joint, landing nipple here, packer. We have SSD here, side pocket mandrel. Sometimes we have a sliding side door, a flow coupling, sliding side door, this one. It depends on the design of the completion. We have subsurf safety valve, self-control subsurf safety valve. It is installed about at depth about 300 to 500 feet, plus minus. So then the wellhead. You see, this is the kill wing valve. This one, this is the flowing valve. This is flowing valve. This is swab valve. Here, master valve, and here the tubing hanger. This one. So you have to take an idea about this is a typical permanent completion. We have Christmas tree also. This is conventional Christmas tree, we call it. This is compacted. You see it, one piece. This is one piece, we call it. And this is the wellhead from top, from swab valve top till the different casing strings that were run in the hole. This is the wellhead. We call it all wellhead, from here to the Christmas tree. And here we can talk about also the hydrocarbon traps. When drilling, we can see a shape of the reservoir, and inside it we have the hydrocarbons. At the top we have the natural gas, below it we have oil, then water. When we produce from the wellhead, from here to the flowing valve, then to the flow line, then to the gathering station, we call it. You see, this is the station, we call it GS, or gathering station. The gas is separated and is sent to the gas station using the compressors. Water is this is separated also and is injected in some wells to boost the reservoir pressure, and the oil is processed and pumped to the gathering station for oil. Then there will be treatment for oil. After that, there will be exporting for this oil. Well intervention. Yes. Sorry for that. Electricity has gone, so there is a problem, unexpected problem. Anyway, we can continue. With well intervention, which is any operation that is carried out on oil or water or gas well during the or at the end of the productivity of the well, which alerts the state of the wells and well geometry. We have different types of well intervention, such as slick line. This is the main type of the operation of well intervention that can be carried out in the completion and in the well, including gauge cutters, removing plugs, setting plugs, removing wireline, retrievable safety valve, and so on. All of these we can use different sizes. The main two type sizes of a slick line is 0.108 and 0.125 inch OD. And we have carbon steel or stainless steel. Stainless steel with high H2S. You see them? These are the wire line, electric line. So two types. We have slick line. This is mainly stainless steel, and this is a braided line, which can be two types also, depending on the this part from the inner. You see them, and we have also for fishing we have another type. Here we have a slick line, the wireline tools that can be done. So you can take a wide range of knowledge by reading these data, and here we can take the standard wireline tool string, which is mainly consisting of rope socket, stem bar, mechanical jar, knuckle joints, the running tools such as plug, safety valve, and so on. So all wireline tools are available with the following the connections, the types of connections. You see, this is the standard wireline tool string: rope socket, stem bar, mechanical jar, and knuckle joint here. And we have here either gauge cutter or running tool or plug or subsurface safety valve. The most common applications of safety valve wireline, which is like this, slick line. This is including wireline and slick line together. So tag, TD, gauge cutter. Why? Because here we see that PLT, TDT. PLT, TDT should include surface readout. So if we run a spinner inside the well, we have to see how much is the rotating speed of this spinner if we want to do correlation also for any zone, for perforation, for everything. So we can use it with wireline. We call it wireline. Wireline including slick line and electric line. Fishing operations, we have these also. If we have any problem in the well, we can fish it. The second type, we call it a braided line. Braided line, we can use it for fishing slick line or swabbing the well. The main size is a 3/16 inch. We have electric line. Here we have three main operations that we can do with it: logging, perforation, and water shuttle. Logging, this is our aim from this course, to monitor the reservoir performance during production period and adjust production or injection based on that. So why do we do the logging operation? To monitor the reservoir, for reservoir monitoring of its performance during the production period, and adjust, either increase or decrease the production or injection based on that. We do analysis for this data. Depending on that, we can take action. Suppose it, not us as production engineers or the people or the staff who is responsible for this field operation. We have petrophysicists, we have reservoir engineer, we have in the town, I mean. They have also software that can analyze these data and suggest the correct action. So they can do that, and we can implement it on the location, on the way. We have also perforation. This is the final stage of the well completion to make a connection between the wellbore itself and the formation. So conduit or we can make it a connection to allow the reservoir fluids to enter from the reservoir to the wellbore. It can also add another interval for production. So if we have 20 feet, we produce from them either to add additional 10 feet or 20 feet additional, we do additional perforation, or we can isolate the producing zone if we produce water only. So we can set MBBT, mechanical bridge plug tool, then 3 meters or 10 feet of cement above it, then do perforation above it. This is called water shuttle. You see it, water shuttle, to isolate part of the reservoir or completely if water cut increased. Perforation, here we can talk about perforation. You can read it and take all data that is required for you, either perforation overbalanced or underbalanced. You see, these are the tools that we can run the logging tools inside them, inside the well, and use pressure control equipment. Coil tubing is part of the well intervention methods. Also, we can do many things such as logging, which you see. The logging is the first operation that we can use in the well. We can do cementing, nitrogen kick-off, coil tubing convert perforation, open and close SSD stimulation, fracturing, scale and sand clean out, milling, fishing. You see, these are the coil tubing package here, coil tubing. You see 2 wells here. And here we have nitrogen tank and nitrogen unit. This is unit pump. And this is pumping unit. This is the rigger for coil tubing. So mechanical bridge plug tool, MBBT, that's what I thought. And then dump cement above it. Coil tubing, we can do perforation also through the coil tubing. This is coil. Now we come to our main objective from this session and from this course. Well logging, we have 2 types of logs, open hole logs and cased hole logs. Open hole logs, after drilling the well, we do survey using these logs, which includes many types, but the program asks us to do this for logs. Not we don't do randomly such logs because it is very expensive. So each run it may cost you $10,000, $20,000, maybe plus minus. It depends. So we have to be accurate. Not us. We do the program on the website. There will be coming from the main administration of the company that identifies that you have to do this log at this time, this log at this time. So we have to know what types of logs that we run in our wells. After drilling the well, we call it open hole log. And after running the completion, perforation, and put the well on the production, we call it cased hole log. So open hole logs, we have resistivity and spontaneous SP logging, micro resistivity, spontaneous, induction logs. So all of these we will go into details for each one of them. Acoustic log, we have cement bond logs, CBL. We have nuclear log, gamma ray, spectral gamma ray, density, neutron, porosity, carbon, oxygen, geochemical, pulsed neutron, lifetime. We have also nuclear magnetic resonance, NMR log. We have mud logging, sonic logging, specialty logs. What are they? Open hole caliper, casing color locator, CCL, casing inspection, borehole imaging, downhole magnetic surveys, and we have video. Now let's move on to the cased hole logs. What are they? We have temperature log, radioactive tracer log, noise log, diverting spinner flow meter, continuous and full bore spinner flow meters, and so on. But these are the main cased hole logs that we run in normal operation. You see this one, the difference between open hole log and cased hole log. You see here, this is the well bore, the well bore, and there is no casing run inside it. This is the rope of the well, open hole log. You see it? And we have, this is the tool, running tool. You see radioactive source here. And we run it using the logging truck. We saw it just a while. Right. Here in the cased hole log, what is the difference? We have casing here. Casing, and behind the casing, we have cement. And we run the tool. Same tool with logging truck and electric cable. We run it down and up, do passes through the interval, and we collect the data and do analysis for it. You see, we have, this is open hole, this is cased hole. Open hole is more reliable than cased hole. Why? Because there is no barrier between the tool and the rope. You see, there is here no barrier, only the fluid. And this fluid in the well, we know it, the brine or mud or water, whatever. In this case, we can do correction for the readings and take the accurate, about 99% accurate readings. While here, you are not guaranteed because that the data will be 100% accurate. Why? Because we have here the fluid in the well, and we have casing, we have cement, we have pollution, we have everything. So you are not sure here. This is more accurate. But sometimes after producing the well, you have to do the log, and here do the log and obtain the data to know how to produce the well or inject the well for the next 10 years or 20 years. So here you are mandated, it is important to run this log. Even the accuracy is not 100%. Now we talked about the difference between the open hole and cased hole. That's what I told you. Important for drillers and operators. Well logs are measurements acquired at specific depths of the well that identify subsurface formations. So after we drill this formation, we have to know where is the oil, where is the water, where is the gas, and depending on it, we issue the casing program. We do the completion program, we do the perforation, we do all of these. Where do we set the packer, where, and so on. Depending on it, we do analysis for it, and after that, the well should be put in the production. This yearly journaling system has evolved to encompass lowering logging tools into the wellbore via wireline in order to measure porosity. Here you can measure the porosity, resistivity, permeability, temperature, water saturation, oil saturation, and all of these. You can, in this way, calculate how much is original oil in place, how much is the reserve of these hydrocarbons, and so on. So you can. It is very, very important while logging, while drilling techniques have transformed drilling operations to include real time. We talked about real time. You read this reading, it goes up to the logging truck, and you see it. You see that here the resistivity has changed. The resistivity of the water is low. Why? Because it has salt inside it, so it can conduct or transfer the signal, while for gas it is not conducting. So there is difference in the signal and in the readings between water, oil, and gas. So from this, we do interpretation. We can do confirm where is the water is, where is the oil is, where is the gas is, and depending on it, we can either keep the well without casing and cement, or run casing and cement, continue drilling, or stop drilling, run completion, what type of completion, produce from the upper zone, from the lower zone, from the middle zone, and so on. So it is very, very important. We're drilling without doing this type of logging, it is nothing. So you have to build data in order to make your decision. Open hole logging here refers to logging operations that are performed on a well before the wellbore has been cased and cemented. We mentioned that just now. When we drill the well, we have to analyze, run the log, and do analysis, and then we can take decision. In other words, the logging is done through the bare rock sides. There is no casing and cement. Bare rock sides of the formation. This is the most common type of logging method, because why? Because the measurements are not obstructed. There is no barrier between the formation and the tool. That I mentioned that just now for you. And it is done during or after the well has been drilled. Okay, during drilling, we do this zone, then we can continue drilling to the bottom zone and do drilling, then logging. So either during drilling or after the well has been drilled. So two cases. On the other hand, cased hole logging, here we have barrier between the formation and the tool. It involves retrieving logging measurements through the well casing. There is casing here, or the metal pipe, or we have this completion. So we do survey through the completion, tubing, for example, and casing. So two pipes. The signal should penetrate tubing first, then the casing, then the cement behind the casing. So the accuracy is not 100%. So we have to take this disadvantage in our consideration. That is inserted into the well during completion operations. Now, case hole logging is performed more rarely, but still provides after the main production, the main logs are done during drilling or after drilling the well. But rarely we do this cased hole logging because it provides valuable information about the well, especially when we have different zones in the well and we want to know which zone is producing water, which zone is producing gas, which water, oil, and so on. So in this case, we can take decision either to isolate part of the formation or isolate the formation completely and go to the upper zone, perforate, stimulate, and put the well in production. Cased hole logging is used to help operators obtain additional information from a well or reservoir that has already been completed. We mentioned that after producing the well, we see that water cut has increased significantly. We want to know what is the source of this water, where is it coming from? In this case, we can do logging. After logging, we can identify the source, and after that, we can put the corrective action. Why do electric logs have to be run in an uncased hole? Now we have uncased hole, open hole, or bird hole. Unfortunately, density logs must be run in uncased holes. So the density should be run with the with no casing and cement in this part of the formation, and are strongly affected by the differences in hole diameter. Thus, the curve recorded for a cave or enlarged part of a well may simulate the curve of a pool bed. This type of logs, density log, should have bird hole, not cased hole, because it is affected with this case. Now, another question: what is open hole wire logging? Open hole logging refers to the logging operations that are performed on a well before the well bore has been cased and cemented. Okay, I think that it is clear. Before casing and cementing. In other words, the logging is done through the bare rock sides of the formation. We saw it just a while. Here, types of well logging. We can see electrical well logging, radioactivity well logging, sonic, miscellaneous. So we can go through them one by one. Types of well logging. Logs can be classified into several types under different categories. We need the permeability and the lithology logs. We can use gamma ray log, self-potential, SP log, and caliper log. These are three types, main types, in the whole world. If you want the porosity logs, what to do? You run density log, sonic log, or neutron log. If you want electric log, you run resistivity log. So I think it is clear for you, but in the course we can go into details and take the case study for each one, and you will see by yourself that this reading is related to oil, this is related to gas, this is related to water, and so on. Well logging here is used for formation evaluation to determine the size of the reservoir we talked about it. You say that we have 20 feet wall thickness, reservoir thickness, 20 feet is oil. If you have this wall thickness or the thickness of the reservoir, and you have the dimension in the field, and you have the saturation, in this case you can calculate the original oil in place. For example, 5 million barrels in this field. If you produce 100 or 1,000 barrels per day, in this case you need X month and X years. If you want to produce 1,000 barrels oil from this field, in this case you may produce from this field for 10 years, and so on. This is the work of reservoir engineering, to determine the size of the reservoir. This is the dimension and the amount of oil and gas in place, and how to produce them for the future during 10 years, 20 years, 30 years. This is done by the reservoir engineer. The following parameters can be estimated from different types of logging tools. You can obtain the borehole diameter, reservoir thickness, this way we talked about it, porosity, water saturation, rock type, lithology, and so on. All of these data you can obtain them, and after that you can use the equation how to calculate the original oil in place, or we call it reserve. Well logging principles, we have log acquisition, types of logs, geophysical logs. We have gamma ray, resistivity, sonic, neutron density, depth meter, and borehole imaging. Production logging, we have a pressure, temperature, spinner, and fluid density. We have well inspection. If there is we have a problem in the well, for example, we can run video, we can run caliper. If you have cut in the tubing, also it can discover it. Electromagnetic, ultrasonic, RA tracer. You see, there is much variety of logging types, tools, principles, procedures. All of these, you have it in this. The subject cannot be covered in 1 or 2 courses, I think. It takes too many days and too many lectures to be covered. Look at this one. This is gas formation characteristics. For the gas, you see, you have all of these logs, and you run it to this. You see, this is SSG2. It may be the well name, and this is the depth. You see it. This is meter, and this is time. At 2020, at 2000, this is the time versus meter. And here you can see that in this we can conclude that we have gas here, we have oil here, below it we have water, and so on. You see, this is gamma ray API. You see this one. This is the middle late Eocene. This is the age Miocene. P, and so on. You see, is the age of the reservoir, of the rock, and the type of the rock. And each one, sonic, gives you like this reading. And here density, it can give you another reading. And if you mix them together, and after that you can conclude which type of lithology that you encounter during the logging. You see this one? This is one well. This is another well. This is the 7, 9, 6, and so on. You see? This is correlation. We call it correlation. I think petroleum engineers have taken them during the study at the university. Here also, we can take it. Well log technology type, information provided by the technology. Here, the lithology and density tool, it can give you the rock density and lithology. Compensated neutron tool can give you porosity and lithology, and so on. Well logging, commonly classified by the kind of energy that is input, active systems, or received passive systems. So you have electric log, nuclear log, all of these, they are repeated, but they are the same methods that we use in our wells worldwide. Well logging introduction. Here also. You see, this is while drilling geophysical well logging. This is the type. This is the mast of the derrick. This is the derrick drilling mast, and this is the tool on the wire line. Wire line. We run and do run up and down. You see it? The logging procedure consists of lowering a logging tool on the end of the wire line. This is the wire line, running logging tool at the end of the wire line, this one, into an oil well or hole to measure the rock and the fluid properties of the formation and make decisions about the drilling and production operations. You see, it types also we repeated them. Types of well logs. Now we can take one by one into details. Lithology logs. We have 3 types. We will go through into details. Spontaneous potential SP, gamma ray, and photoelectric effect (FEL). We will take one by one. Lithology logs, you see, it can be obtained by many techniques. A sonic log, so lithology log, we can use the these types. Sonic log, internal transit time is recorded. So you have sender and receiver, and between them, what can you receive? The sending time and the receiving time through this row, and there will be delta t, delta time. This delta time, the passing through the rock. If it passes through the dolomite, it will be different if it passes through the rock with gas inside it, with rock with oil or water. So in this case, you can differentiate. What does lithology? So here we will not go into details here. We will have a quick look at them, and we can go into details during the course. What type of log do we use for lithology identification? Here, neutron and density logs. You see, each react to both lithology and porosity. So by analyzing the two logs together, one can begin to distinguish lithology from porosity. So for shale, the porosity is high if it is compared with dolomite. So when we see high porosity, very high porosity, we say this is shale. For the range of reading between this number and this number. If it is higher, if it is lower, and we can see it very easy. Neutron and density log together with a caliper measurement recorded by the density tool and a natural gamma ray log are commonly run as a combination. We run them together. So if you have gamma and density with the neutron, they can give you readings. You can conclude that this rock is dolomite, this rock is sand, this rock is shale. Because the main types of the rocks that we deal is sand, shale, and calcium or dolomite. So it is very easy. Sandstone or limestone. We have sandstone is one. Most sand grains are quartz. So maybe feldspar, which is usually pretty low. In radioactivity, limestone, so these will be taken later. The other type is spontaneous potential log. You see it. This I will not explain the principle of it. You can see it. You see at this porous permeable bed, we have shale up and down. The porosity of the shale is high, but the permeability is almost zero. Here is zero. While here, it has high porosity and high permeability sandstone. You see? Here also spontaneous sand and shale. We can take it here. And inside it, what is the liquid inside it? If it is water, oil, gas. Spontaneous potential log also, you see shale, sandstone, sandstone. Here also, we have sand, shale, shale. This is the logging tool, SP electrode. Here, we have H1. For example, for shale, it gives a high reading. For sand, it gives low reading. You see this one. Here, a clean sand, thin clean sand. Sand. While with shale, it is high. With clean sand, thick clean sand, you see low, almost zero. Here, here also, SP. This log is very important. So sand here, limestone is high, and so. Density log, you see gamma ray, SP. Gamma ray with SP, we run three types of logs together to make sure that the conclusion is very accurate. Lithology using the gamma ray log. Gamma ray log is very important and can confirm. You see, this is the gamma ray in green. This is the green. You see it? For shale, it has high reading. Limestone, middle reading, and sandstone is low. You see, siltstone is medium, sandstone is low, and shale. You see the shale has high radioactivity. Sandstone is low. So from this quick look, you can see, you can conclude that here, for example, what is inside it, we have gas here, we have oil here, water, and so on. So you have to differentiate. First, the type of the rock, and second, what is inside this rock, whether it is oil, water, or gas. Here also, caliper, also we can see it. Here gamma ray, you see with shale, high, limestone, low. Shale, limestone. Shale, sandstone. Sandstone is very close to limestone. Dolomite. You see it? Shale is high. While here, a neutron, inside the shale, here, there is nothing. Here. While inside dolomite, we expect that there will be gas here, or there will be oil. You see neutron porosity. Here also, with shale, we don't have any fluid inside it. It is cover rock. We call it cover rock. It prevents the movement of the fluids up and down. You see it here. The black one, this one. While here, porosity, it has high porosity, but permeability is almost zero. You see, here also high porosity. While here we have high porosity, like dolomite, high porosity, but here, what do we have? Gamma ray. Where is it? Here is the gamma ray, high for shale, but low for dolomite. But the neutron, it is high. You see it here. Density, porosity, it is high. Density, porosity, high. Okay. So porosity logs, we have density, neutron, and acoustic sodium. And each one, we can take examples. Porosity logs. What is the unit of porosity? Porosity, it doesn't have any value. It is, what is the expression porosity means? It is the ratio between the volume of the pore of what to the rock volume completely. So the spaces, the percentage of the spaces inside the rock to the total volume of the rock. It may be 0. It may be 10%. It may be for shale. It may be high. Maybe 20, and so on. You see porosity, this is the porosity. And here, lithology, the types, 3 types of logs we can see and compare for shale, sandstone, and for here gas, gypsum, anhydrite, dolomite. Density log also, we have formation density log. For each one, you see dolomites between gram per cubic foot, a cubic centimeter. These are the, this is the range for dolomites. This is for sandstone. From this one value to this value, and so on. This table is showing density of various lithologies. So in the lithology, in the this type of log, density log, in gram per cubic centimeter. So if it is between this 1.9 to 2.65, for example, it means it is sandstone, and so on. So you have to use more than one log to explore, to know what is the type of this rock and what is inside it. Neutron log also, you see, for shale, for quartz, sandstone, limestone, dolomite, shale, and so on. Here, for sandstone, you see, here we have gas in the top, oil, and water. How do you differentiate it? By the neutron. You see the neutron here, gas effect, this one. It gives more neutron porosity units. And here for water and oil, it is less. And so, acoustic log also, you see it here. Porosity evaluation, resistivity logs, all of these. Water saturation, we can calculate it from the equation. This equation, the reservoir engineer uses it, and also petrophysicist can calculate the water saturation for this reservoir. Here, resistivity logs. Induction log also we can use. What is induction resistivity? So these lateral logs, you see, different types of logs. We have videos also. If we want, during the course, we can introduce videos, can explain more and more. You see here, dual lateral log, LLD and LLS. Deep, D and S. Deep and shallow. Two types. Dual lateral. Micro resistivity. So I think the time is passing. We need to spend more time on them. This is specialty logs, FMI, full bore formation micro imager. Also type, you see, every day there is a new invention that is introduced to our industry. So formation micro imager, FMI, this is famous tool that can be run. You see it, FMI. Gamma ray log, we talked about it. You see, no gamma ray for the sun here. For the shade, it is high. Also, here, gamma ray, and you see here, we conclude here that we have sand, reservoir sand, below is shale, and above is shale from the gamma ray. From the resistivity, we say that we have water here, and we have hydrocarbon here. Then we go to the neutron porosity. Neutron porosity can differentiate oil and gas. You need to understand this concept that in the bottom we have shale, at the top we have shale, and between there is sand. From this depth to this depth we have water. From this depth to this depth we have oil. From this depth to this depth we have gas. And depending on it, we can build our decisions for the completion. We have casing collar locator, CCL. This is very famous. Log, gamma ray CCL log for correlation, for perforation. Without this log, you cannot do perforation. CCL, casing color locator, correlation log. This is for perforation. You see, this is measuring the wall thickness of the tubing or the casing. So this is the body. You see the body. It is known 30 feet for the casing. And here is the color. So we call it casing color locator. Color. We do correlation between reference log and the log that we run now. So do shift 1 foot up or 1 foot down or plus minus, and this is the reference for us. This gamma ray is not changing by time. It will stay for 10 million years or 20 million years. It will stay constant. So we depend on it. After drilling the well, we do this reference log, we call it gamma ray, and depending on it, we do our correlation log. You see it here, correlation log and reference log. This is the reference log. We depend on it. We keep it in our file, in our company office, and we use it when we want to do the correlation log. We do shifting up or down. We are, this is open hole log, reference log, and this is cased hole log. The gamma ray is not changing. You see, if it is down here, we can shift it, the correlation log here, say 2 feet or 1 foot from here to here. You see, so it should be like this. There is no difference between them. Cement bond log, CBL and VDL, also for the cement behind the casing. Ultrasonic. It is very interesting, and here cased hole logs for production, temperature, radioactive tracer log, noise log. This is for communication behind the casing. We can use it. Diverting spinner flow meter for the production of each zone, of each type of each part of the reservoir. We produce from here oil or water, or we have to do water shut off. So the action is taken from here. Continuous and full bore spinner flow meter. Temperature log also, if you have any problem in the hole, if you have any crack or damage in the casing, in this case, the temperature will be higher, abnormal. You conclude that there is a problem in the casing here, and in this case, you can take decision to move, work over and fix this problem. You see it here. Radioactive tracer, also slug tracking, noise log. We talked about it. 2 days log. First day it will be the background, and the second day will discover what is going on. You see here, there is communication from water sand to gas sand, from here to here. And here we hear a noise, not us, the tool. It hears the noise, and we conclude that there is here, what do we call it, noise or abnormal voice. So we conclude that here we have communication from the water sand to the gas sand. Diverting spinner flow meter, so different types. Continuous and full bore spinner flow meters. Corrosion log, also very important to see if there is any corrosion. Applications, you see. Here, the last section is the reservoir monitoring plan. During the well production of the well, we run wireline tools and do, for example, bottom hole closed in a pressure survey, bottom hole flowing pressure survey here for oil wells and gas wells, PFO for pressure fall off survey for water, PBU for oil producer, interference test between two wells. Here is injector well, here is producer well. So we inject here and produce here, set gauge here and gauge here, and then we can analyze the data from both gauges. Integrity test also, capacity test, modified isochronal test for gas producer or gas injector. You see, this is an example for bottom hole closed in a pressure survey. We run the gauge inside, the well is closed. Then when we pull it, the pressure will go down. This is modified isochronal test, open and close at different size of the choke at surface. Here you see open bottom hole pressure, open close, final shutting here as if built up here. Here you open quarter choke value, then half volume, half size of the choke, then 3/4, then full open. Here in the beginning it was full open, then open here, close, from here to here, close. For example, 12 hours. Then open 12 hours with 25% of the choke size. Then close it for 24 hours. Then open for 24 hours at 50% of the choke. Then 24 hours close, then open 24 hours with 75% of the choke. Then 24 hours close, then here, then open at 24 hours. Then close it. You see it here. This graph is related to the operation here. Opening size of the choke, quarter, 2/4, 3/4, and full open. Here we have observer well and active well. If we want to measure the reservoir pressure, we don't need to close this well because it is an active well. If you close it, in this case, you may make it quit and you lose it. In this case, you have observer well very close, maybe 200 meters away from the active well. You can measure the reservoir pressure here. So it is very important. Questions and answers. I think we finished about 1.5 hours or like this. So I think it is too much. And I hope that you got benefit of it and enjoy our session for today. Mr. Nikhil. Mr. Nikhil. Here we have a question from Mr. Daniel. How many times do we do logging like we have wildcat wells, appraisal wells, development well, etc. So we do logging for all of them. We mentioned that during the logging, during the drilling of the well, what do? We do logging after drilling this section, or till we reach to the end of the drilling to the TD of the well. After that, we do drilling, depending logging operation, and depending on it, what do we do? We do make a decision. How can we produce this well? Where do we have reservoir, oil, water, gas? What type of completion, single, dual, and so on. In this case, we can see what is the action, what is the plan for production or injection for the future for this well. And during the production of the well also, we can see where, when do we do this log. For example, I tell you, if we have water cut increased from 0 to 50% or 20%, you have to investigate where is it coming from. So we run a PLT log and see, produce the well and see where is this water coming from. Either to do isolation or to do whatever action is required, then you can reduce this water cut and bring the well back to the norm. I think this is the answer for your question. Mr. Nikhil, I think he is not with us. Thank you for you, everybody, and hope that you enjoyed our session for today, and hope to see you in our course next month. Thank you very much. Thank you. Goodbye.